Today I am going to talk about basic engineering drawing. In that we will be discussing about various engineering drawing instruments. So for drawing or engineering drawing we require some instruments. These instruments are very necessary, very basic for making any drawing for any engineering purpose. So these engineering instruments they should be they should have some qualities. That is, the quality, accuracy and precision of the drawing depends on selection of proper use of instruments. So we should select proper instrument to get the required accuracy, required quality and precision on the drawing sheet. So to get a good drawing we need the instruments, the proper instruments, and we have to know about those instruments which with which we can deliver a good job. So we use different types of instruments in engineering drawing. These instruments are classified into some categories. That is, basic instruments and tools for drawing a straight line. We require some basic instruments to draw a straight line, that is like scale, and tools for drawing curved lines, that is to get arcs, curves or circles or some parabolic curves, hyperbolic curves. All these curves we have some special tools to draw the curves, and also some tools to measure the distances, to mark the distances, to measure the angular distances and linear distances. We need some instruments. Similarly, some special equipment which we need for drawing. So some basic instruments which we use in our engineering drawing are a drawing board, a T-square, a drawing sheet, pencil, eraser, fasteners like clips, tapes, etc., or pins, drawing pins, set squares, clinograph and mini tractor. These are the basic tools which we require for a good drawing. So we cannot give a good drawing without these instruments. So one by one we will discuss about each of the instrument. Similarly, for curved lines we need a compass, a some set of French curves and some templates. For measuring distances, we need divider, protractor, a scale. Under the category of special equipment, we have a drafting machine. So let us go into details about the construction of a drawing board. Drawing board. Generally, drawing boards are made of soft wood. In our colleges, we may have uh, steel or iron tables, or sometimes mm, other type of materials. But generally, as per standards, there should be a softwood drawing board for drawing the engineering drawings. So these boards they are not monolithic or made of one plank. They are made of made by joining several planks or softwood. So they make a groove and they insert another plank into that groove and they make a board. So these wooden boards are made of very soft wood, so that we can insert some pin into it. And also while drawing, it will not make any dark impression. So below that, by after joining that boards, these boards are joined by wooden battens and cleats. That is, they all the planks are joined, and then in the other direction they have two battens, which are which on which for which we put the cleats. So that completes the construction of a boat. And also this the purpose of these cleats patterns are, the purpose is that they hold the all the planks or wooden strips, and also they stop warping or bending. That is, they stop bending of the or change in the plane of the boat. So for this purpose, they divide the board into several strips. That is why many strips are joined, and also they are connected by a batten. So on the one of the shorter side, they have a ebony small strip, a straight edge. So on that straight edge, the T square, that is T square, now it is almost obsolete. Generally, engineering students are not using. Only some architecture students are using. It is a instrument which is in the shape of T. So the shorter arm or the top of the T will travel on the ebony strip, which is perfectly straight and supports the T square. So we have IS Indian Standard Code recommends following boards. So IS 1962 has recommended some sizes of different boards, because for standardization and uniformity for making manufacturing of boards or using of boards, these boards are also standardized. In our earlier class, we have discussed that what is the necessity of standardization. So everyone should who is using a drawing board should follow the same drawing boards, same size, same specifications. So the sizes of the drawing boards are given by IS in its IS 1962 code. So the board sizes start from B0 to B3. It is four types of drawing boards are there. So the first size is B0, that is 1500 mm into 1000 mm, that is 1.5 meter into 1 meter. A large board which is generally used in design offices and other important offices. And B1 board, which is that is 1000 into 700, 1 meter into 0.7 meters. That is the common board which we use. The next is 700 mm by 500 mm. That is 700.7 meters into half a meter. That is 0.5 meters. B3 board, that is 500 mm into 350 mm. These are all the sizes of boards. If you observe these sizes, the 1500 into 1000, the length is 1500, the width is 1000 for the BO size. When it comes to B1 size, that 1000 mm has become the length of the board. So subsequent board is equal to the width of that the earlier board. That is B0 board has 1000 mm width. That width has become length of B1 board. Similarly, they gradually they come down to the B3 size. So the sizes are 1500 into 1000, 1000 into 700, 700 into 500, 500 into 350. So these are all the sizes, standard sizes of boats. Now we have to use standard sizes of drawing sheets for drawing. So these drawing sheets are also standardized so that everyone uses the standard sizes and they maintain the uniformity. They are generally a thick paper sheets which are which has a very glossy side on one side and slightly matte finish on the other side. So we generally do the drawing on the glossy side. That side, the range of drawing sheets are from A0 to A4. We have 5 types of drawing sheets available for engineering drawing. So the A0 size is, these are trimmed sizes, that is from company. Actually untrimmed sizes are different. After trimming, that is after cutting them into proper size, they become 841 into 1181 mm. So this 841 into 1181 is 1 square meter. So 1 square meter is 1 square meter area of the drawing sheet is proportioned in such a way that it is 841 mm into 1189 mm. Then that next size is 594 into 851. A2 size is 420 into 594. A3 is 297 into 420. A4 size is 210 into 297. So these are the 5 sizes which are available for drawing. If we observe the width into length sizes, the width of A0 becomes length of A1, and also the length of A0 is 1189. For A1, the width will be half of it. So if we compare every consecutive size, the width will become length and length will become half, and it will become width of the next size. That is, the next consecutive size will be, the width will become length and the length of the previous size paper, half of it will become the width. So the process will continue, so that if we place one sheet on the other, it will be half of the previous sheet. So we can say the surface area of A4 size sheet is 1 square meter, and also the length to the width ratio is 1:2. We can observe that it is 1:1.414 size. The ratio will be that size. If you observe the previous A4 sheet, so 841 into root 2 will give you 1189. Similarly, 420 into root 2 will give you 594. So these are the sizes. So width of higher size, as we discussed, as I said earlier, the width of higher side will become length of subsequent lower size sheet. Half of the length of higher sheet becomes the width of the subsequent lower sheet. I have taken an example of A4 sheet. A4 size width is 841 mm, which becomes A1 size length. Similarly, A1 size width is 1189. So half of it will become length of A1 sheet, that is 594. Layout of drawing sheets. So drawing sheet should be laid in such a way, that is the layout, the drawing, the lettering, all such things should be in such a way that the main objective of drawing should be that the prerequisites of drawing sheet should be they should be easily and quickly readable. That is, once we see the drawing sheet, the drawings on the drawing sheet should be easily readable, and we should be able to understand them quickly. Next, they should have required drawing information. That every sheet should have enough information such that what is the drawing about, what are the sizes, all those information should be given on the drawing sheet. Then good appearance. A drawing sheet should be good. You should give nice appearance. It should not be crumpled. It should not be clumsy. It should not be cluttered with many drawings, and it should give neat appearance so that it should be aesthetic. Then facility for filing and trimming. The drawing sheet should be such that we should be able to file or we should be able to trim them. That is, once the drawings are made, we have to store them, we have to keep them for a longer time. So the for filing, it should be is properly foldable. So hence that facility should be there for the drawing sheet. So drawing sheet should be easily and quickly readable. It should have all the drawing information. It should have good appearance. It should be such that the filing and trimming is easy. So we should, many in drawing offices and many other things, lots and lots of drawings will be there. They have to file in cabinets or files. So for that, they should be the drawing sheet should be properly foldable, or we should be able to store them in properly so that we can easily pick them up and in a smaller space. They should occupy smaller spaces properly and neatly. We should be able to stack them or store them. So on a drawing sheet, some important component is there. That is, it is called as a title block. Title block, as the name suggests, it is the block which has the title and also some other required information about the drawing. So a title block is generally placed at the bottom of the right corner. So on a sheet, it should be at the right corner. So this area, if it is the sheet, this area should be occupied by the title block. So the standard ISI, according to ISI, the standard size is 185 by 65 mm. For title block, the standard size is 185 mm by 65 mm. So the IS has given some model title blocks. So according to these title blocks, we have many companies or institutions, they follow these title blocks for depending upon the specific purpose. So what is the necessity of a title block? What it is? As I said, title block is a small block or a table like thing which lies at the corner, right bottom corner of the sheet. So when we look at the title block, it has some information in it. That is, it stores the information like title of the drawing, what is the drawing about, or sheet number, scale, what is the scale followed for drawing that drawing. So sometime you know what is a scale. Sometimes we reduce the scale, we increase the scale. Large dimensions cannot be fit into the small sheet, so we reduce them according to some ratio, 1:100 or 1:50. Some scale we bring them down, or sometimes we enlarge them, we scale down or scale up depending upon the necessity. So that scale we will give. So what is actual scale on the ground or of the object, and what is the scale which we have drawn this drawing. So this information is given in the scale. Similarly, name of the firm, the firm which is which has taken up the drawing, which has taken up the job of drafting the drawing. So the firm which has prepared the drawing, and also the firm for which the drawing is prepared, and who has drawn the drawing, um, who has gone inspected or corrected the drawing. All those information are given. So similarly, what are the highest standards which followed for drawing or for making the component? This is information. All this information is given on the title block. Next comes the tools used for drawing a curved line. So generally, as you are aware, as you are, we have been drawing circles, arcs using our compass from our maybe 6th or 7th class. So we know what is the compass. So how to draw a circle or arc using a compass. So it will give a circular arc or circular curve. To draw a circular arc, circular curves, all these things we use a compass. So normally we use normal compass. Sometimes for very small circles below 2.5 mm, 2.5 centimeters, sorry, then we use bow compass. A bow compass is a small compass which is specifically used for drawing small circle. Otherwise, normal compass, we have different types of compass in our geometry boxes or drawing instrument boxes. We find a compass, and also some other instruments called as French curves. These are these are curves, or these are ready-made curves which are made into a which are uh, made like grooves in a plastic sheet, generally on a plastic sheet. So they have different uh, radii of curvature, and also parabolic curves. Many different types of curves are engraved, not engraved, they are etched into uh, there will be grooves in those shapes. So we can use those grooves to draw the different shapes depending upon our necessity. So there will be several curves given on the French curves. So using them we can have different parabolic or hyperbolic curves, or sometimes even the circular curves can be drawn by adjusting the French curve on our points through which the curve should pass. Templates. Templates are ready-made shapes. Ready-made shapes which are made on the metal sheets or plastic sheets. They are, as you know, nowadays many students are using Pro Circle. That is a circle which has many holes in the shapes of circle. So different uh, circles of different radii are made on that plastic sheet. So ready-made, we readily can use those circles or sometimes oval shapes by using them. They resemble our stencils. You might have seen in your earlier classes the stencil, that is the alphabets are grooved on a plastic sheet, so that by inserting a pencil we can we can easily write the alphabets. Similarly, these templates can be used for different drawings. So they are ready-made drawings, ready-made shapes which use for quick drawing. So we can simply, no need to measure the radius and use a compass. Simply by putting the template we can draw a circle or a ellipse or some other standard shape. So it aids us in drawing, in getting a quick and easy drawing. So they are ready-made templates. So in engineering drawing, we use different types of lines. That is, lines, as you know, they may be straight, zigzag, curved, all those different wavy, different lines. But in engineering drawing, we generally use curved lines, straight lines, and very limited types of lines. So in engineering drawing, these straight lines, generally straight lines, depending upon their thickness, their what we call it as weight, and also the how continuous they are, they give different meanings. So every line has its own purpose. So we cannot draw one line for the other. So these thicknesses and continuities are well predefined. So according to the IS code, each line has its own meaning. So we have to keep in mind what that line is intended for. For different applications, we have different patterns of lines and widths of lines. That is, the line may be continuous, it may be like a chain, or it may be a dot dash line, or like that. So depending upon the situation, necessity, we use them accordingly. So we in engineering drawing, we use these types of lines. That is continuous narrow line. So we use a continuous narrow line. That is, narrow means here the width is narrow, the thickness of the line. We say the weight of the line. The weight of the line is narrow line. So it is used for extension line, dimension line, leaders line, hatching, etc. So when we see this continuous narrow line, we should understand that it means that this line should be either extension line or dimension line or leader or hatching lines. So according to these categories, this narrow line should be used for only for these categories. Similarly, continuous zigzag lines. So we make a zigzag line continuously. So for showing the cuts or sections or limit of partial views. Suppose if the drawing is very big, we draw it up to some distance and we show the zigzag lines, that is, it is only the partial view. Here we have make a cut. So to convey that, we use the zigzag line. Continuous wide lines, that is, the thickness is slightly bigger. Then we use it for visual outlines, boundaries, etc. So for drawing the boundaries, visual outlines, we use a slightly thicker line, that is wider line, which is continuous. So when we see the continuous wide line, we should understand that it is showing a visual outline or a boundary. Continuous extra wide line, that is, it is still more bigger line, that is thicker line. The thickness is the narrow line. If narrow line has 1 unit thickness, the medium line will have, the wider line will have 2 units, and extra wide will have 4 units. 1:2:4 ratio they follow. Suppose the thinner line is 0.5 mm, the wider line will be 1 mm thick, the still wider line, the extra wide line will be 2 mm thick. So visible outlines when hatching is not done. When hatching is done, we use wide line. For extra wide line, when hatching is not done, we use this. And also in civil engineering, for reinforcement bars, that is the steel rods, we use the extra thick line, and also lines of special importance. We use dashed wide lines, thicker wide lines with dashes, that is discontinuous lines for hidden outlines. Suppose some hidden lines are there, we show it by using dashed wide lines, that is thicker lines with dashes. Long dashed dotted lines, suppose long dash and some dots and again a long dash. These types of lines are we use for indicating the center line. when we want to show a center line or a line of symmetry, a cutting plane, reference lines, we use a discontinuous line, that is a line, a dash, some dots, then line, long dash, small dots. So such a line, that chain line, we show it for representing the center line, cutting planes, lines of symmetry, reference lines, etc. Similarly, full dotted lines. These dotted lines are used for outlines of parts that are not included. When parts are not included, we show some parts which are not included, then we show by dotted lines. So these are the different types of lines which we use in our drawings to show different parts of a different um, different parts of an object, or different um, what should say, the representation of the parts, whether it is outlined or inline, or it is a symmetrical line or cutting line, depending upon the whether it is a extension line or dimension line. So depending upon our requirement, we use those lines to represent those particular ideas. So now we come to the mini tractor, because as I said earlier, in olden days they used to use t squares and set squares draw to draw parallel lines and perpendicular lines, also of given of required inclination. So generally you might have used your geometry box in your earlier classes. We have a small geometry box here. A divider, a compass, protractors, so we use set squares. You might have seen in your drawing box a set square which has for both corners at 45 degrees, and another set square which has 30 degrees and 60 degrees. Right angled triangles, you have two right angled triangle shaped generally plastic pieces which are right angle triangle shaped with one is isosceles triangle, the other is 30 degrees and 90 degrees. So earlier they used to use these set squares and t square for drawing parallel lines. So by carrying them, handling the t square and all these things is cumbersome thing, and transporting them is very difficult. A long thing, a long t square and set squares, protractor, and maintaining the edges, it is all difficult. So recently, maybe some 20, 30, 30, 40 years ago, the a mini drafter, a replacement for t square and set squares are taking place. It has completely eliminated the use of set square, except some architecture students and some special artists and other people. T squares are now dispensed with. They are not using because of its their inconvenience and the convenience of a mini drafter. As a mini drafter is a replacement for a t square, set squares, protractor, scale. So all those four items, they are made into a single item, which is very easy and convenient to handle, use. So it has become very popular now. Universally, mini drafters are being used by students, and bigger size mini drafters are being used in drawing offices and other offices. So what is a mini drafter? A mini drafter, as the name says, instead of a big drafting machine, we have a small mini drafter, a portable, convenient, easily handled instrument called as mini drafter. It is a very convenient and powerful drawing instrument. It is one substitute for T-square, set square, scales and protractor. All these are substituted by a single instrument, that is the mini drafter. Parts and their functions of a mini drafter. So a mini drafter is a very simple instrument made with a simple mechanical connections. So it is a ingenious instrument, very well conceived, well made instrument, which has changed the entire scene of engineering drawing. So it has some parts, that is, it has a clamp, it has a link mechanism, it has a head which contains the protractor and scales, which has some pivot, and also the knob. So let us discuss what is the purpose of each part in the mini drafter. So we have a clamp. That clamp itself says that it is used for clamping or fixing. So our mini drafter is fixed to the drawing board. Generally at the top left corner. On the top left corner we fix the clamp, and it has a knob. By fixing the clamp, by rotating the knob, we will fix the clamp so that there won't be any movement. So once it is fixed, there won't be any movement. That is, only the link mechanism can be moved, but instrument will stay in its position rigidly. Then link mechanism. Link mechanism is some links. It is a movable made of rivets, generally rivets. So this link mechanism is easily movable. So we can move the scale and protractor easily from one part to the other by dragging them. Next comes the pivot plate. It has a pivot plate, a plate which has a small aperture at the center. So this plate which contains the protractor, scales, and also it can be rotated about a pivot point. So there will be a pivot plate on which the head can be placed. So pivot plate is attached to the link mechanism, which is a small projection, small pivot, so that we can put our head, that is the drawing mini drafter head on it, and we can clamp put the knob. Next is protractor head. That is, it has a protractor head, protractor, and also the two perpendicular scales. So that head contains two perpendicular scales and a circle on which protractor is etched. And at the middle of this head there will be a hole which can be placed on pivot, so that we can pivot or we can rotate the protractor, or depending upon our requirement. There is a knob which arrests the movement of head. That is, protractor head. If we release the knob, we can rotate the protractor head to desired position, and we can clamp it through the knob which is on the protractor head. So this is the simple construction of a mini drafter, but it has very good use. It is very useful to the student to draw an engineering drawing. So procedure to fix a mini drafter. How to fix a mini drafter? So before starting any drawing, we have to make some arrangements before drawing. That is, these should be done before starting a drawing. So initially we have to take our mini drafter and fix it on the, as I said, on the left top corner of a drawing board. Once we fix it, so there will be a mark on the pivot head, pivot plate. So on the pivot plate we have to adjust the zero of the protractor. So zero of the protractor and the pivot plate, they should flush, that is they should be on the same line. Then we will arrange the knob. Then our paper, we will align our paper so that it is parallel to the length is parallel to vertical scale and width is parallel to horizontal scale, or vice versa, whatever it is. So the scales and the paper should align parallelly. Then we will put the clips to the paper, or tape, or drawing pins. So thereby we our drawing will be in a proper alignment with the drawing sheet. Otherwise the drawing sheet and the drawings will be have different alignment. They will be inclined to the drawing sheet. If we read, it will be very awkward. Then once they are fixed, once they are properly placed, then we can drag the mini drafter using the by virtue of the link mechanism. We can simply drag the mini drafter scales to the desired position and we can draw the lines. If we want inclined line, slightly we will open the knob and we will fix the scale to the desired position using the protractor, and we will arrest the knob and we can draw the lines in any required inclined position. So after making all these arrangements, let us discuss about some useful tips for producing a good drawing. A good drawing needs some care, some skill. That is, for getting a good drawing, we should take some necessary steps. We should be careful. So a crumpled, a smudged drawing will not look nice, and it is not proper to submit a bad drawing with bad smudges or foldings, all those things. So for that we have to maintain the drawing sheet very carefully. While folding or unfolding, we should take enough care so that the drawing sheet is in its good shape. Before taking up any drawing, ensure that you clean your hands and the instruments. All the instruments should be clean, dust free. Generally they will have that when we sharpen the pencil, then there will be the lead powder will stick to the instruments, so they will spoil our drawing sheet surface. So before starting any drawing, we have to clean our instruments, clean our hands, keep our hands clean, so that the sweat or any dust or anything will not spoil our drawing sheet. Then whenever we draw, the pencil should be sharp. So drawing with blunt pencil will give you thick lines which are not uniform. So keep it in mind that every time, for every line, the sharpness should be same. The width of the line should be uniform, so that frequently we have to mend our pencil and make that tip of the pencil sharp. Nowadays, traditional pencils are replaced with using the mechanical pencil. So we find mechanical pencil, different kinds of mechanical pencil in the market, that is 0.5, 0.6, 0.7 and 0.8, similar range. So we can use any mechanical pencil which give the uniform. There is no need of mending those pencils. Simply their tip will be of constant thickness, that is 0.5 mm. So they give uniform lines. So nowadays instead of cumbersome maintenance of pencils, mending the pencil, uh, sharpening the leads, all those things, they now students are preferring the use of mechanical pencil. So these tips also we can have two types of pencils, two types of tips for traditional lead pencil. That is a chisel head. We can use a sandpaper or emery paper and make it like a chisel. So these heads we can use for drawing straight lines. They give uniform lines. Other is our normal conical shaped tips. Pencil should be well sharpened. Never sharpen pencil over the drawing board. So near the drawing board, never sharpen your pencil, because due to air or something, the lead powder will fall on the drawing board, and when we touch the drawing board, they cause the smudges. So the powder will damage the appearance of the sheet. It will become black, and it will give bad appearance to the drawing sheet. So whenever you sharpen, you never sharpen near the drawing sheet. Instead of one pencil, it is better to keep some pencils sharpened already at home or out of the away from the drawing sheet, and clean your hands so that your drawing sheet will be in a good shape. The general tendency of any general tendency of students or many draftsmen are, that is placing their arms over the drawing sheet. They bend over the drawing table and place their drawing sheets on their hands on the drawing sheet. So this habit should be avoided. The dust and other grease on your sweat and grease on your arms will stick to the drawing sheet. So you should never bend or place your arms on the drawing sheet. Also, some people have bad habit of not proper planning, improper planning. They don't plan their drawings well, so every time they start erasing. So frequent erasing will take away the glossy coat on the drawing sheet. So it makes the drawing sheet rough, and the appearance will be lost. Good appearance will be lost. So as far as possible, plan the drawing so that there will be very, very minimal erasing. Also, the compass and the divider leg should be sharp, so that the blunt tips, they won't pivot properly. So when we rotate or when we measure, they give wrong lengths, or the curve won't be proper, so it will slip. So as far as possible, we should never use uh, dividers and compass as a nail or a needle. So their tip should be properly maintained. We should take proper care of their tip, so that they won't go blunt, and when we pivot them, they stay properly on the sheet. Handle on all instruments with care. Many drafters, all instruments, we should take care so that their links or their screws will not become loose, and they won't give us proper lines. So our mini drafter, we should be able to draw parallel lines. When we are unable to draw parallel lines using mini drafter, very closely spaced parallel, we should test using the mini drafter by drawing the closely spaced parallel lines. When they stay parallel, then mini drafter is working fine. Otherwise, the link mechanism, or there is some fault in the mini drafter when the parallelity is not maintained. When closely drawn lines are overlapping, or when they cross each other, that means they are not parallel. That is, there is some problem with the instrument. So to avoid all these such problems, such mistakes, we have to maintain the instruments properly. That is, we have to fold the papers properly, keep them in a nice box. Also, we should fold our mini drafter properly, keep it in bag, and maintain them properly so that you can get the good result. So now we have come to the conclusion of the chapter. For during this conclusion, let us have a small recap about all the items which we have covered in this session. So the quality, accuracy, and precision of the drawing depends upon the proper selection of instruments. So for getting a good drawing, we have good drawing. That means they should the accurate drawing, precise drawing. That is the good quality drawing. We have to choose the proper instruments. So with proper instruments only we can draw a good, accurate, precise drawing. And for drawing, for engineering drawing, we need some basic tools. That is, tools which are required for drawing a straight line, tools which are required for drawing curved lines, tools for measuring distances, that is, and special equipment like mini drafter or drafters. So our basic drawing starts with a board. So IS has recommended four types of boards. That is, three types of boards. It is B0, B1, and B2. These are three types of drawing boards which are recommended by the Indian Standard Institution. That is Bureau of Indian Standards. So according to their recommendations, we have three sizes. That is BO size, B1 size, and B2 size. That is, BO size is 1.5 meters into or 1500 mm into 1000 mm, and B1 size is 1000 into 700 mm, and B2 is 700 into 500 mm. And also it has given, the IS has given the paper sizes, recommended paper sizes which are standardized after trimming. That is, after trimming the sizes are A0, A1, A2, A3, and A4. These five sizes are there for papers. That is, A0 is 841 into 1189. A1 is half of the 1189. That is 594 into 841. A2 is 420 into 594. A3 is 297 into 420. A1 is 210 into 297. These are the different sizes of papers. You may be knowing, you commonly use A4 paper for normal writing, normal assignments, all those things. We generally use A4 size paper. If you observe that A4 size bundle, it gives the total number of sheets, the GSM, and also the size of each sheet, that is 210 into 297 mm. It is a standardized size of a paper. So for any drawing sheet there are some prerequisites. That is, it should have some characteristics or qualities. These qualities are that it should be easily and quickly readable. So we should be able to read the drawing very quickly and easily. So reading a drawing paper should not be difficult. It should not be cumbersome. So all the drawings should be such that they should be easily readable, and it should be quickly readable. And each drawing should have required information about the drawing. All the information about the drawing and the scales, what is the drawing about, for whom it has drawn, all that information, tolerances, specifications, all those things should be incorporated in a drawing. And it should have good appearance. A drawing should have neat appearance. It should not be clumsy. It should not be unclear. So it should not be cluttered with many drawings. So every drawing should have neat appearance. Then a drawing sheet should have facility for filing and trimming. That is, we should be able to trim them, cut them, or we should be able to fold them to store. So every drawing sheet has a title block at the bottom right corner. The IS recommends the title block as 185 centimeters into 185 mm into 65 mm. That is 185 by 185 length and 65 width. This is the standard size of any title block. So title block is, there are some models given by the IS code. According to those models, we can use the title block. So the title block is meant for giving the information about the drawing. All the information, necessary information about the drawing is put on the title block. So the title block is a legend, or it is a information area which we get the information about drawing. All the information regarding the drawing is written in a title block. So in engineering drawing, we use different types of lines. So line is a soul of engineering drawing. Engineering drawing, mostly we use the lines. So all lines represent the are used to show the object. So these lines, they have different thicknesses, continuity, and patterns to show to convey what type of line or for what purpose it is being used. So this is for this reason we have different types of lines. So each line has a defined meaning and purpose. It has a specific meaning and specific purpose. So we cannot replace one line for the other. So every line has specific, definite meaning and a purpose. Next comes the mini drafter. So mini drafter is a replacement for a substitute for all the clumsy equipment like T-square, set squares, protractor, scales, which we need for drawing. So all these instruments put together into a one instrument, then that instrument is a mini drafter. It is a very convenient, easily carryable, portable instrument. So as I said, it has some parts like clamp, a pivot head, a protractor head, pivot plate, link mechanism, all those things for making the drafter easily movable, and also some clamps and knobs to make it perfectly aligned with the sheet to draw parallel lines, exact precise parallel lines, and also lines which are inclined depending upon our usage. And we have some tips for good drawing. That is, always we have to keep our hands and instruments clean and neat so that smudges are not found on the drawing sheet. Next, the pencil heads and compass tips should always be sharp, and we have to avoid frequent sharpening of pencil, and also we should avoid resting our arms on the sheets. So these are all the necessary tips to produce a good drawing. Thank you. So this brings us to the end of the topic, the drawing instruments, and what are all the instruments which are necessary for producing good drawing, starting from drawing board to mini drafter, scales, instruments for curved lines. All those instruments we have discussed, and now let us take leave. Thank you one and all.